Hello everyone, this is Professor Leon Zhang from the University of Connecticut, Department of Electrical and Computer Engineering, and the Director of Undergraduate Studies. And here in these following videos, I'll show you as an electrical engineer what you will expect to learn, to do in our department throughout your 4-year studies. So one of the most exciting experiences at UConn gotta be the senior design project, where you will team up with a few other students and apply what you have learned in your past 4 years of studies and apply them to solve a practical problem. The projects themselves usually come from an external company, and this is one of the senior design projects in our department featured in the local news. The project was sponsored by Sikorsky, and the topic is to develop an autonomous firefighting drone. 3 undergraduate students participated in this project and developed both the hardware and software solutions. As you can see, the drone itself takes a pretty good footprint and can be flown to locate the fire using the thermal camera. During the process, the thermal camera will scan the ground, pick up the thermal images, and of course, the position or the location with the highest temperature is supposedly where the fire is located, and the drone will be flown on top of the fire, drop a fire retardant. In this version, they use a water balloon to put out the fire. And here they're showing the drone being tested on campus, and the drone picked up the heat signature from a fire pit on the ground. Okay. Sikorsky has been developing and sponsoring this project for a number of years, and they plan to continue their efforts to further perfecting the solutions in the future. In modern electrical engineering, robotics control has become one of the most important application fields. In this video, you see a humanoid robot trying to pour a bottle of water into a cup. This action seems to be simple from a human perspective, but when we're looking at a robot, we have to make sure that all the joints, which are implemented using electrical motors, are coordinated together such that the elbows, the shoulders, the wrist, and also the fingers of the robot can work together smoothly and complete the pouring action. In addition, we have to also make sure that the camera embedded in the robot can recognize the location of the cup, the pose, and the location of the bottle, such that the pouring action is done in the best possible manner. But in everyday life, things are not as simple as this. There could be disturbances. For instance, in this video, you see now a human operator tried to mess up with the robot and change the location of the cup. And of course, the robot now has to adaptively change, replan the motion of all the motors involved and still complete the pouring action with minimum disturbance effects of the disturbance. Now, the third part of this video, we're going to show an obstacle avoidance capability of the robot where the camera will pick up the location and adjust the movement of the robotics arms such that the motions of all parts of the robot will not collide with the obstacle object in the middle. Now, this part is very important in more robotics applications because many applications require a robot to work in close proximity with human operators instead of working in an isolated cage. And of course, in those scenarios, robot doesn't necessarily have to take a humanoid shape. In this case, we're looking at an iRobot, which is similar to the Roomba robot we use in our life to clean our floors. Now, in this case, this robot must locate the green markers on the floor and follows these green markers. This is similar to a self-driving autonomous vehicle, where the vehicle is commanded to stay in the lane even if no human operators are involved. And again, in our department, we have faculty members working in this particular type of applications. And a common application, of course, is a self-driving vehicle. And this self-driving vehicle could be on the ground, as our cars or trucks, and could be even underwater, like submarines, boats, ships, and so on. Another important area in our department is power systems. And one of that field is electrical motors and drives. As we know, electric motors and drives are the heart and soul of the robot arms and of course of electric cars. To make sure the motors work smoothly, can adjust its working regime smoothly, and to develop advanced analytics to diagnose any potential fault in the motor are all important topics in our instruction, education, and research in our department. In electrical engineering, one of the important fields is controls, as we have seen in the previous few videos. And this video shows a very interesting application called inverted pendulum, where a stick can stay upright with only the support from the bottom, which is connected through a hinge to a card on the platform. Now, not only this balance can be achieved, even if someone applies disturbance trying to break the balance, the card can detect the offset and rebalance such that the stick never falls to the ground. Now, this is accomplished in the lab environment, but it has profound applications in a number of ways. For instance, the Segway vehicle that we see nowadays, the hoverboard, use basically the same working principle, where the wheels and the platform work as the cart underneath, and the stick in this lab equipment, just like a human body trying to stay upright and balanced on the cart. Not only that, think about the scenario where you want to shoot up a rocket into the space. The rocket itself takes the shape like an upright stick, and the only place where you can apply major thrust will be at the bottom of the rocket. So you're basically looking at an inverted pendulum in the sky and furthermore in the space. And how to balance the operation of a rocket system, make sure it's propelled to the right direction without falling over, tip over to fall to the ocean or to the ground to cause a disastrous scenario is very important. It's a very important control problem. Now in this video, we're showing another control application where you see a steel ball hovering mid-air without touching any surface on top or underneath. And the reason it can hover in mid-air is because there's a magnetic field generated on top of it, and the magnetic force pulls the steel ball up to cancel and compensate for the effects of gravity. Now this particular application is called magnetic levitation, and it's the working principle of a bullet train and some elevators involved. And the tricky thing about this application is that it's an unstable system. If the ball moves too close to the magnet on top of it, the balance will be broken. The magnetic force would become the dominant one, override the gravity, and pull it further and further, closer and closer to the magnet. If it moves further away from the magnet, gravity will become the dominant factor, and it will be moved farther and farther away from the magnet. So trying to find that balance, maintain the balance is the major challenge, and algorithms have to be developed to solve that challenge. In the department, you'll be taking classes, understanding the working principle, the theoretical part, and naturally there's a lab component that will let you apply those knowledge to work with this lab equipment called maglev and to test your understanding of the theory. We must first ensure the safety of the human operators involved, and this requires advanced. In this last video, we're looking at what we call the seesaw balancing device in a lab environment. The balance of the seesaw is achieved only when this card stays in the middle. But again, because of different scenarios in the real world, the balance can be broken every now and then. So in this video, someone tried to tip over the balance of the seesaw by touching one of the arms, and you can see the card adjusts itself to quickly recover this balance. Now, this application is important in a number of ways, and one of the things that you have seen recently in daily life is to find someone using a handheld device for image stabilization when they try to shoot a video or take a photo. And of course, the working principle behind them is to apply some of the control mechanism shared by the seesaw balancing equipment. Application. From the videos you have seen above, you should have learned about what electrical engineering is about. All the videos you have seen are either taken in our research and instructional labs or about the work that the students accomplish as part of their academic requirement. If you want to know more about our department, about electrical engineering program, feel free to come to our website at www.ee.uconn.edu. Algorithms and analytics for the robot to recognize in real time where the obstacles are, the human operators are, and accomplish the job while ensuring the safety of everyone involved. Now, robotics is very popular in these days. In our department, we have faculty members working in this area, and a new robotics program is underdeveloped by the ECE department as well.